Alrighty, looks like the stream begins now, or so says the little timer, and I think we know from experience the timer is never wrong. So, welcome back everyone to Handmade Hero. I hope you have had a good weekend. This week, in our quest to build a complete game from scratch, we are going to be getting some user input and getting sound output working, if all goes according to plan. Not that there is much of a plan, but if all goes according to what we would like to get done. Let's put it that way. So, if you are following along with today's lesson and you have pre-ordered the game on handmadehero.org, you can go to your zip file and unpack the day 5 source code. That is what we are starting with here on day 6. Now, the thing that I want to talk about today is basically how we are going to get input basically from a gamepad, if that makes sense, and also how to get it from the keyboard. So if we take a look here, I'm going to search for something called X input so you can see what I'm talking about. X input is basically the current way that you have to use to get the kind of gamepads that almost everyone actually uses with games now, which are like Xbox 360 controllers. Microsoft, for whatever reason, they introduced their own sort of interface layer for getting controller input. It was called direct input. And then they turned right around a couple years later and decided that they were just going to ignore that entirely and make a whole new one called X input. And so that is what you use now, and they're not even really compatible. X input controllers will show up in direct input, but I guess you can't send rumble messages out to them potentially, and also you can't get the audio handle for outputting audio to the controller's plug, these sorts of things. So if you want to support gamepads properly, you pretty much have to use X input because that's what everyone has. You can go implement direct input if you want to be able to support kind of legacy controllers that maybe don't have an X input driver, but on the whole, you're pretty much going to have to support X input at a minimum. And now what X input looks like, thankfully, it is actually one of the simplest APIs to use on Windows. It is very, very simple. You can actually see, I don't know which one of these has in the MSDN has a good introduction, but I think basically any of these probably has a good, yeah, here you go. So basically all you really have to do is code that looks like this. You loop over the number of controllers that there are, you go ahead and you get the state of each controller, and the state of the controller is basically a big old structure that just has all the stuff that you might want to know about the gamepad. And so it is really absolutely trivial to do, and we will be doing it today. Hopefully we won't hit any snafus, but that is basically it. Now, in the old days, if I remember correctly, you couldn't actually include an X input header file. That's what I want to say. I want to say that was true. But I guess I'm going to assume that maybe that is not true anymore and that we'll be able to sort of directly include it, but I'm not actually sure. So I'm going to go ahead and fire up Emacs, and we're going to see basically what our situation is here in the modern world of programming. So I'm going to go into Handmade. I'm going to launch the trusty Emacs that is, you know, always our trusty editor on every platform. A little bit slow, a little bit aging, but it gets the job done most of the time. And I'm just going to see straight up if I can include, I believe it was xinput.h, because I don't even know if that exists on platforms. And it does. So basically xinput.h holds the definitions of all of the stuff that we actually want to use to get our input. So what we're going to do is we're going to go down here. Now if you remember, we have a game loop. It's really kind of a very beginning of a game loop. I mean, it barely does anything, but we have one nonetheless. We go through here and we process our Windows messages, then we do our rendering, and then we go ahead and blit that rendering to the screen. So what we're going to do is right here after we get our messages, because these are messages that are going to come in to do keyboard as well. A keyboard will come in through here. The X input is a polling-based API, which basically means that it only gives us back the state of the keyboard, the state of the controller when we actually ask for it. So we have to ask for it at some point, and that some point is going to be here, right after we do this. Now, something that we should note, and I'm going to put in a little to-do about this because we may decide that we want to do this later, should we pull this more frequently? So what you have to understand about input devices is there's two methods of getting input from input devices oftentimes. There's interrupt and polling, sort of a vague way to think about them basically, but an interrupt-based input scheme is one where whenever the controller itself, whenever the thing that you're actually getting input from, the device, the external device, whenever that device actually needs to tell you that something happened, like something changed, a button got pressed, the state of the stick wiggled, something like that, it will actually send you the data, right? So basically it's controlling, in some sense, when you need to wake up and process it. Now that sort of thing doesn't really happen very much anymore, but in the old days that actually used to be literally true. There used to be actual interrupts that would happen on the CPU that would actually say, hey, this device has something to say. Well, that doesn't really happen very much anymore. For the most part, what happens is things are either pulled or they're kind of a networky sort of thing where they kind of send packets to you and those packets kind of get buffered up or those sorts of things. So in some sense, it's sort of like an interrupt, but instead of actually interrupting you, you're really just reading a stream. Either way, since this API involves us actually polling the X input controller and asking for its state, we may get into a circumstance where we want to pull it more frequently than every frame. Now, I don't know that that's necessarily true. 60 frames a second worth of polling may be plenty, or it may not be. And the only real way to know is by sort of playing with it and testing. There is some stuff we can do inside X input to actually kind of get a feel for how frequently we're polling it relatively to how frequently it would like to be polled and things like that. But we'll get to that later, because right now we're certainly not going to care about that until we're actually doing the like real serious final stuff for the Windows layer, which we won't do up front. Those will be things we do kind of more towards the end of Handmade Hero. So inside the documentation here, you can see I've got the different functions. You can see that X input is a pretty small API, and that's a pretty good thing, basically. That is what you want. So looking at it, basically X input get state is primarily what we need. Get X input get state is the thing that actually returns the state to us. So all we really have to do is we just have to call this, but we have to call it with this thing called DW user index, which if you look at the documentation here, it says the index of the user's controller. So as you know, Xbox controllers only allow 4 controllers. They've got those little sort of quadrants that they fill in. So there's only 4 that are allowed to be there. But if I remember correctly, there actually is somewhere in here, there is a pound defined that says how many there are. I want to say that is true, but I don't see it listed here. It just says a value from 0 to 3, which is kind of unfortunate. There it is, X user max count. So that documentation was just a little stale. You can see that this is basically the loop that you want here. You go over each of the controllers, and in case they ever increment the number of controllers that are necessary, we know that we would get them all by doing this. So we can just basically use that pound define right there that lets us know. Now, I don't really love I necessarily, so I'm just going to go ahead and say that this is the controller index, just so we know what we're talking about here. And then I'm going to go ahead and expand this out. So there we go. Now we are looping over all the controllers that we might possibly have. And now we are going to pass that controller index, and we are going to ask it to give it back the state of our controller. So this is the state right here, and we pass an address of that thing, and it will fill out that address for us. So there we go. That's basically X input. Now it's going to return to us a piece of information that's whether or not the controller existed, I believe, if I'm not very much in error. So let's take a look. Yeah, controller's not connected. So basically, if it equals error success, you gotta love things like error success. If it equals error success, then that means this controller is plugged in. And if it doesn't equal that, if it equals any other error message, then that means that the controller is not available. Now maybe that could be an error, maybe that could be that it's just not plugged in, but basically what happens is we can't actually do anything with this controller here. So that is actually information that we need. For example, we may want to show in the user interface that a controller has been unplugged. We may want to take action on that. So this is not necessarily just an error case. This is actually a case that we want to handle in the future. Right now we don't need to because we don't have any logic, but in the future we may want to handle that. Okay, so all we're going to do here is we're going to actually look at this controller state. Right? We're going to take a look at the sort of things that we can get in it. And if we go in here, I guess, let's see if I've got a good, where's a good, there it is, X input get state. So you can see what it's got here. It basically has a packet number. And again, remember when I was saying just a few minutes ago, I said that basically there's a concept of the device sending you pieces of information perhaps, or being pulled at a certain frequency and that sort of stuff. Well, this packet number is basically sort of increments every time we know about the state of the joystick changing. Now, I don't really know, since I don't know the internals of how X input works, I don't know whether it's the driver that's thinking about that, so that the driver internally is polling it more frequently and incrementing that, or whether the controller itself actually manages that. I suspect it might be the controller. I'm not really sure. Doesn't matter either way. Point being, when we pull the state, we get back a number that basically says what where we are in the series of state changes for this particular controller. So if we missed a bunch, if we pull it and it says 5, and we pull it again and it says 30, we know that there's a bunch of states that the controller went through, maybe buttons that got pushed or the stick got twiddled, that we never actually saw. And that would be an indication that we might be pulling it too infrequently. Now, it doesn't necessarily mean that, because it may be that it just gets sampled at a really high rate and we don't actually care about that because the user can't actually press and unpress the button at a rate that's that fast, or things like this. So we don't actually know, but at least it'll give us a little bit of an sort of an informational boost, right? So basically all we're going to do here is we're going to say, okay, the controller, when we get it back, we're going to get that thing. So in the future, maybe we'll take a look at that. I'm gonna say that DW packet number. I'm gonna actually write that in here as a thing to maybe look at. See if packet number increments too rapidly, and then we're gonna look at basically this gamepad piece. So I'm gonna snap a pointer off of this thing, so we don't have to keep talking about controllers state dot gamepad. I'm gonna actually grab x input gamepad star pad equals the address of that. And that's just syntactic convenience, so we can just talk about it like this. So the x input gamepad is the only structure we've got defined currently. As you can see, it's got a bunch of fields that correspond to the things on an Xbox gamepad. Shocking, I know, but that is all that happens. So W buttons is basically a bit field. You know those bit fields. Again, I think it's funny because people in the Intro to C stream were asking how often you do bit manipulation, and I'm like, we do it all the time, and man, we have done it a lot, and all we're doing is implementing the Windows layer, right? And we've already done a ton. So that W buttons field, it's basically an ORed together version of these fields right here. Now it's a word, which means 16-bit. That's Windows for 16-bit value. Byte, 8-bit value, 8-bit value. Short, 16-bit signed, right? So we've got the buttons, and the buttons include the D-pad. Those are considered buttons, actually, since they can either, I don't actually know why they're buttons, because they're mutually exclusive. You can't really press the D-pad like left and right buttons at the same time, but there you go. That's how they work. We've got the start, back, the thumb buttons, like when you press them down, the shoulder buttons, you got the A, B, X, and Y, and then you've also got, on these things, the triggers are analog, so you know how far the user pressed them down, so those are actually bytes that range from 0 to 255, depending on how pressed they are. And then you've also got two XYs for the two thumbsticks, the left and right thumbstick. So, it's real self-explanatory. There's almost nothing that you really need to learn here. I mean, it should be real self-explanatory. I'm going to take a little almond milk hit, and then we're going to take a look at these. Okay. So, basically what we're going to do here is we just want these things, out. And the question of what sort of stuff I actually want to get for this game, this game is kind of an old school game. So I suspect that mostly what we're going to be looking at is those 4 buttons, as I really don't know that we're going to want to do much other than the 4 buttons. And maybe the 2 shoulders, yeah, like the 2 shoulders, these buttons, maybe the start and end, I don't know, the D-pad. I'm thinking most of the stuff we want in here. Triggers is probably not going to be very useful for an old school game. I don't suspect, because, if you were playing an old SNES game or something like that, you probably didn't have a lot of like first-person shooting or that sort of stuff, so I don't know that those will be very useful. And these, well, I don't know. It depends on whether we want to. The reason to support these guys, even though we're probably not going to want them as much for an old school game, is that, well, I think we all know the Xbox 360 Gamepad's D-pad was not that great. So if you're talking about the Xbox One, you could probably play on the D-pad and be very happy, but we may need to support the thumbsticks just because that D-pad on the 360 was so bad. So it looks like most of the stuff we're actually going to want. We don't actually need to do anything with it yet because we don't have much defined, but basically what we're going to do is we're just going to go in here and sort of mark out the stuff that we actually care about. So we care about these things. We care about basically whether this is down. So I'm just going to kind of line these up here, and then we'll take a look at them as we go. So let's just take all the things that we need. So we want D-pad up, we want down, we want left, we want right. We kind of want to see these things. We want start and back. That's good. We're going to want left thumb and right thumb, left thumb and right thumb. And we are going to want A, B, X, and Y, I think. Oh, not thumb. We're going to want shoulder. We don't actually want thumb. I don't think we want thumb. Thumb is always hard to press for me. A, B, X, Y. There we go. Okay, so we've got up, down, left, right, start, back, shoulder, left shoulder, right shoulder, A, B, X, and Y. So I guess we'll call these A button, just to be clear about what that is. There we go. So that would basically decrypt into Booleans, right? All the things we might want. I don't think we want those triggers, but we are going to want that left thumb, I think. We're going to want that left thumbstick. So we're also going to want here something that's basically the int16 of the, I guess the stick left, what should I say? Stick horizontal, I guess would be it, or stick X maybe, let's call it, and stick Y are the two things that we are going to want. So we're going to want to grab those out of the pad as well. S thumb LX and S thumb LY. Now the question of whether we want the right thumbstick or not, I think we're going to need those buttons, so no one's really going to be able to use it, so we can just leave it there. So that is basically, as far as I know, I'm trying to remember if there's anything else that we actually need. What did I do here? Oops, that D-pad's not supposed to be there. I'm trying to think if there's anything else we need. I didn't bother to delete the D-pad part of this, which is kind of a mistake. There we go. I'm trying to think if there's anything we actually need, but I don't think there really is. That's probably all we need to get out of these. And we're going to get them for each of the 4 controllers. Now we'll have to decide whether we actually need multiple controllers in the future, but that's basically what we're doing there. And the thing that you'll have to notice now is that X input get state is again something that we have to link with. Now, there's a little bit of a complication here. And I was trying to decide whether I wanted to handle this today or handle this in the future. And I think based on the time that we've got here, I think I probably want to handle it today. That's my thought, because we've got a lot of time. And it's not that much work to get that X input get state. So you'll note that we've got what we had many times before here. Unresolved external symbol, X input get state, referenced in function, win main, right? And so basically that's exactly what we were talking about before. And as you know, I taught you what to do in this circumstance. You basically just need to look at the function, wherever that function is. And inside that function, it's going to have a thing down at the bottom of the MSDN documentation that will tell you what you need to link with. So you can see it here, and it's got it, right? Now, the problem that you will see is, it's got it here. It's got some stuff listed, right? What's the DLL? Oh, it's 1.4 or something, blah, 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 right? The problem that we have is that this platform requirements line is a little bit sketchy, right? It's like, okay, it requires Windows 8, potentially, which we know that most people don't have because nobody wanted it, right? So that's not happening. DirectX XDK, well, we don't really know what that means. What version of it do they mean? And does the user have that installed? I don't know. We haven't actually used anything from the DirectX SDK, but when we do, we'll probably use one from a very early version of the DirectX SDK, basically. So we can't really guarantee that that's going to be on there. And Windows Vista, well, what if the person was running Windows XP? I don't know. I don't know why Windows 7 isn't listed here. Presumably if it was in Vista, it would work on 7, but I don't know. So you can see that it makes me a little nervous. So what I would rather not do is I'd rather not link directly to xinputlib. Because if we link directly to xinput.lib, then what's going to happen is if it can't find one of these DLLs on the system, then our game just won't load. Just flat out won't load. And that's kind of annoying because you don't need a gamepad to play this game. We're going to allow you to play it with the keyboard at a very minimum. And so it would kind of be bad if you couldn't launch the game due to due to xinput when you otherwise could have totally easily played it with a keyboard in the circumstance where there wasn't an xinput library. So what do? How do we resolve this external symbol problem? Well, what I wanted to introduce you to was the concept of basically loading Windows functions yourself, essentially. Basically getting the code into your executable for a Windows binding and looking up the function pointer so that you can actually call directly into it without using an import library. And this is actually a really simple process, And especially in a circumstance where we have such a small number of functions that we actually need to deal with, in this case, possibly only 2 that we might need to deal with total. I'm looking here, let's see, what is X input enable? Do we need to call this? Let's see, in response to get input state, state will be registered but not sent to the device. I don't know if we need that one, but pretty much we're going to need get state and set state is probably mostly all we're going to need, because set state allows us to send vibration out, and we may want to vibrate the controller in response to things. That kind of adds a little bit of fun to a game. So we may want set state as well, but that's really all we're going to need is X input set state and X input get state. So what I want to do is basically I want to kind of come in here, and I don't know if I don't actually know how good the browsing is. Oops, I'm going to open up devenv and get back to our program in the debugger. I don't actually know how good this is. Can this do a open document and jump us to it? Let's take a look. Hello, Windows. There it is. Good job. Okay, so basically we're looking at this, and it looks like it wants xinput 1.4.dll, and that's fine. You can see it defines those here for us if we want to know them. And then you got all the defines in this Windows include header file that basically are all the things we were looking at, right? It's got this one, it's got that. And then this is the part we actually care about here. It has the defines for these 2 things, right? These are the 2 functions we actually care about. And so what I'm going to do is I'm going to say that we're just going to flat out get these ourselves. We're going to load them ourselves from that DLL without actually asking Windows' executable loader to do any of it. So what I'm going to do is I'm going to cut and paste the definitions in here, right? And I'm going to strip out those little in and out annotations, right? Because those are just for the static code analyzer, and we don't actually need those. I'm going to get rid of all this stuff so that we just have the function signature, and that's it, right? You can kind of see it just got the function signature, nothing else in there. Going to get the function signature for this one as well, right? Like that. And go in here and make sure I've got the vibration one there as well. There you go. So now I've got the 2 function signatures. Now what I'm going to do, as you know, if I just put the function signatures in like that, then basically what that's just telling Windows is, hey, by the way, there is an external function somewhere called this, in case you didn't know, and now if I call it, you can bind to it in the linker stage, right? So that doesn't help us because that was already in xinput.h, so that does absolutely nothing for us. But what I can do is instead of actually treating it like this, I can change this into, oops, didn't mean to hit that. I can change this into a type def. I can basically say, I am going to do a type def that tells the compiler there is a function of this type, and I want to actually start declaring variables that are pointers to it, basically, right? So this is actually saying I just want a type called xInputGetState, right? This is the name. I want a type that basically is a function. That's the type of this thing. So you know how you say type def int foo, and now foo is basically a synonym for int. So if I do foo x, I've got an int. Well, if I do this now, if I have xInputState as my type, if I say xInputState foo, well, that doesn't really help me because you can't define actual objects that are functions in C, so that's not going to fly. But what does fly is if I wanted a pointer to one of those functions, I can do this. I can basically declare a pointer to a function that has this signature. And that's totally legal, and that's exactly what we want. So, what I'm actually going to do is I'm going to go ahead and say that this is a global variable, since there's only going to be one of them. We are going to have xInputGetState and xInputSetState, xInputGetState and xInputSetState, like that. And the problem now is we're going to conflict with this Windows header file if we call them the same thing. As you can see here, right, they've defined these. They're not macros or anything. We can't really undefine them. I could not pound include this file, but then I would lose all of these defines that they did for me. I'd have to cut and paste them in. That might be something that I might want to do, but for now, I don't think I want to do that. So we're just going to go ahead and say, well, all right, let's call this maybe dynamic or something like that. I don't know. I'm not sure what the right way is. Let's just dy. We'll just prefix it with dy. So we know this is our dynamically loaded one, and that is what it will be from now on. In fact, you know what we could do? We could do something even cleverer. This may be a little bit too clever for our own good. I don't know if that's actually true or not. Sometimes, but let's find out. what we could do is we could say, okay, let's stick an underscore after them just so we know, and then we'll actually just go ahead and change what the meaning is right here. We could do that. It might actually work. I don't know. Let's see. Let's get wild on a Monday. This basically says, all right, from now on, anytime you see this, change it into this. That way we can still use the real name, but it will always actually remap to our fake pointer. Yeah? Make sense? Hopefully that's clear enough. I'm just making that a little bit more easy because I don't want somebody typing xinput getState in here and calling the Windows function because we're not linking with that. Of course, they would get a link time error, but I don't know. I'd like to try and prevent people from accidentally doing that. So maybe we just do this, and that's good enough. Okay, so let's recompile that. Off we go. And so now what will happen is you'll notice that we have a call to xinput getState, and it's down here, right? That is now defined to actually be this, so it's going to actually call the function pointed to by our pointer, but our pointer is uninitialized, right? It's 0. It's not initialized, it's 0 because it's one of those static global variables. It's 0. So basically what will happen is if we run this program, we will just flat out crash. At least I assume we will. Let's verify that. Yes, we will just flat out crash, and the kind of crash we will have is basically an execution violation. So you remember, we've seen what happens when we try to read and write from invalid memory. We get an access violation. Well, you also get the same kind of access violation if you try to execute memory that isn't valid. And that is exactly what's going on here. Basically what's going on here is we declared a pointer to a function. We did not point it at anything, and then we went ahead and tried to call that function. Well, unsurprisingly, that jumped to 0, 0, 0, 0, 0, 0, 0, as you might expect, and there isn't anything there. So it immediately faulted and stopped our application. So that's fine, but what we do need to do is we do need to basically figure out some way of actually pointing this to something useful. So how are we going to do that? Well, the way we're going to do that is twofold. First of all, and we kind of have two choices here. I'm going to show you how to do one of them, and I'll briefly mention the other. But the first thing I'm going to do is I want to go ahead and stop this thing from crashing in the case where we don't have these pointers. So I'm going to take the ridiculousness up one more level and basically define a macro. This is how I normally do things. This is how I normally do them. I know it's particularly odd. But basically, I'm going to define a macro that defines a function of this form. So basically, it looks like this, right? It is a macro that just outputs that. And oops, I don't know why I keep hitting the insert button today. So basically, if you run this macro and you pass it a parameter, it will basically define for you a function with that name. That is all it's going to do. And then I can replace, I can do the other one as well while we're at it, right? Y input, not Y input, X input set state name. There we go. That's the other one right there, right? Looks good. Oops, got rid of the D word. Didn't mean to do that. There we go. Got everything in there. And looks right. Okay. So basically what we're going to do is we're going to define these two macros that basically define the functions for us. We are then going to define our type def in terms of the macro. So we're basically going to say, well, that's just this, right? That, you can see, this line will now produce this line. So we can get rid of it, right? Same thing again for the set state one. We want to produce this line, so we'll just do x input set state. Oops, just the G there. X input set state. That'll produce this line for us. And then the global variables can stay as they are. Those totally work. And now you may wonder, and then we've got our remapping down there. Now you may wonder, why did I bother doing that? Why did I bother breaking it up in two lines? Well, it's because I want to make functions of this form as stubs, basically, right? So we've defined the types, but I want to actually do an x input get state stub, which is a function with the same signature, but that does absolutely nothing. Just returns 0. That's it. And the same for set state. There it goes. Now I'm going to say x input get state stub and x input set state stub. There we go. Let's compile that, make sure everything's cool, and it is. So I hope you can see what I did there. Basically, this is a very efficient way of defining the function prototype once for the thing you want, defining a type of that so that you can use it from now on as a pointer, and we want to be able to do that, defining a stub with it as well. And now if we need to change this function signature at any time, it'll change it everywhere, right? So it's kind of nice and compressed in that way. Now the stubs, and I might go ahead and do them like this, right? In fact, I might even go a little bit further and say just group these all together by set state or get state. So there's that one and there's this one, right? Yeah, makes sense? So basically, these are our definitions now. This is our support for X input get state, and this is our support for X input set state, right? And all I've done is I've made it so that now our function pointers point to a default function right off the bat. So in theory, now when we run, we will not crash. We'll just do what we used to do. And what will happen is, and we'll see here if I run to it, basically what will happen is this function pointer is just pointing at the stub function. So when we jump into it, we just jump to our stub function, right? No harm done. So basically, that's a good way to initialize your function pointers, to just point to a stub so that if you don't initialize them ever again or fail to be able to load the thing you're going to load, well, it's no big deal. So let's go ahead and call that done for now. And now we got to see how to actually load the Windows versions of those, right? Pretty straightforward. So I'm going to just reorganize that a little bit here. So I'm going to make a function up here just because I want to be able to keep this close at hand. I want to be close to these definitions so I can just see it easier, to be honest. We're going to call internal here, and I've got these, yeah, I got internal, right? Good. Why isn't these should all be called internal. I don't know why they're not, so I'm going to go ahead and do that just to make sure. Yeah, these should all be internal, and they are. Okay. Okay. In fact, wait, but isn't this one, can't this one be internal too? Is that allowed to be internal? Any complaints there? No, it's not, because it's a... Yeah, okay, good. Okay, sorry about that. Just a quick... When I see something in the code, sometimes I'm obsessively going to have to go touch it. That's just the way it goes sometimes. All right, so I'm going to go ahead and define the new function here called load x input. And I guess we'll prefix it with win32 since that's what we've been doing. Load x input is just going to be a thing which tries to get x input if it can. If it can't, it can't. No big deal, not a problem. All right, so what we're going to do is we're going to essentially do the steps that the Windows loader does when it loads our program. So we are going to use a function called load library, which loads basically the DLL, the backing part the thing that Windows uses basically to give us functions, which and we're going to have time in this stream, I think. We're going pretty good here. I might actually draw some diagrams for this one so you can kind of see what it is. We're going to use that to load the DLL that we actually wanted. So we're going to call load library with a file name. The file name is going to go in here, right? And that's going to give us back a module, which is basically a handle to some code, right? A handle to a loaded piece of code, kind of like our H instance was in WinMain, if you remember that. It's that sort of thing. So what we're going to do is get the X input library. We're going to load it, and assuming that we get back a valid library, we're then going to load the functions out of it. So X input get state, our function here, get state, is going to be equal to something that we load out of that library. And I always want to type Y if I type X. Set state is also going to be one. Now the function that we need for that is called getProcAddress, and we'll see how that works in a second. So load library, we need a file name to load, and remember, I was mentioning it before, inside that xinput.h, they actually were nice enough to define for us, for this version of the header file that we're using, which one it is. But to be honest with you, I would rather use the earlier version because that would give us a little more compatibility. Now I happen to know that xinput 1.3 tends to be available on a lot of machines, so I'm going to go ahead and just verify that guy is there. So let's take a look. Let's go ahead and change over here to Windows, and let's do a dir/s. I don't even know if this command works anymore like this, but let's take, oops, that's not good, .dll. I just want to see if it has one of these still there. Sure does. Yep. Does it have before? I don't know. Let's find out. Let's take a look. What DLLs, DLL bingo, ladies and gentlemen, what DLLs do we have? Definitely got xinput 1.3. We got 2 copies of them because you can always do with a few more copies. I think one of them's a 64-bit and one's a 32-bit maybe. I don't know. You can see these in WoW32 and this is in System32, which I think means this is the 64-bit one and this is the 32-bit one. Paradoxically, perhaps, or Yeah, okay. So if we were to try and load X input 1.4, we would not even run on this machine probably. So basically this just kind of gets back to what I was saying about why you kind of want to take this sort of thing into your own hands potentially. If we were to actually let it load it for us, it probably would have failed. So I'm going to try and load X input 1.3 instead of 1.4 because that's going to be on more machines, and that'll mean you don't have to install a bunch of stuff to actually have our game work. So assuming we get that back, I don't know if you have to check for invalid handle value. It is null, so that's fine. So basically, we're going to load that DLL up. It's going to map it into our process virtual address space. We are then going to pass that handle to a function called getProcAddress. And what getProcAddress does is exactly what it says. It gets the address of a procedure or a function. So if we look at that, basically all we have to do is pass the module and then pass the name of the thing that we're trying to load. So we are trying to load xInput getState and xInput setState. Now you will notice, since it does not know, getProcAddress does not know what the function signature is that it's loading. It can load anything, any kind of function. It's just going to return what is basically a void star. So we are going to have to cast the return of this to the type that we actually want, otherwise C will immediately complain. And we know the kind that we want, so that's pretty easy. We just do it like this, get input set state star. And that is that. So we're going to go ahead and compile that, and we're going to go ahead and see if that worked by stepping into it and taking a look at sort of what actually occurs, whether we get valid function pointers back from those. Oops. Of course, that'll only work if we call the function. If we never call the function, we're not going to get much help, I suppose. So that's kind of initialization stuff. So I'm going to just put that right here. First thing we do, we're going to try and load it. If we can, we can. If we can't, we can't. So let's go ahead and see. Can we load it? Loaded just fine, looks like. So we go in here. We'll call getProcAddress. Did we get an address for that? Let's see. xInput getState. What happened there? Oh, right. It's an underscore. Sorry. And xInput setState. We use that macro trick. Makes things a little more complicated in the debugger. It's true. So it looks like we got both of them. And you can kind of see now, if you look in the watch window, it's kind of interesting. The watch window is actually smart enough to tell us that these are now pointers into the xInput 1.3 DLL portion of our memory space, right? Which is kind of cool. So we've got them now. Let's see if we can run with them. We can. And so in theory now, we are actually getting back from Windows the actual state of the controller, which means if we wanted to, for example, we could make it so that something was predicated on that. We could make it so, for example, that we do this little thing here, like we add Y offset. Maybe we will only add Y offset if one of these is down, right? Since this is just our little thing that we play with anyway. Maybe we'll go in here and say, well, if the A button is down, right, let's add to that, right? And there we go. Now, if we're running, we should see no actual Y motion, and that's true. And if we had a gamepad here, which, you know what? I don't see any reason not to run into the other room and get a gamepad and test this out. I don't really think there's almost any chance that there's anything wrong. It's such a simple API. But you know what? Give me 1 second. I'm going to go grab one. Plugged in my TV. Seems worth it. I don't know. Only took a couple seconds. You can see I've even got the one that was sort of the video, and I actually don't think that's true. The one I recorded in the trailer is actually at work. I got 2 of these pink ones. I bought them one time. I bought 2 pink ones and like a green one. They were all they had left at the Target downtown. We were trying to play a game called Gang Beasts, and we wanted extra controllers. So let's take a look and see. I don't know if this is going to work here. It doesn't look too promising because it's not actually lighting up for me, which does not fill me with much hope for the fact that it's actually working properly. But what are you going to do? Let me try plugging it into the actual PC down here. Ah, there we go. That had a little light flash on it. I don't know. That might indicate something good. Not actually sure. Well, Yeah. Well, I don't know. I tried. Let's see if we can get this gamepad working. This doesn't seem like it's going to be much to do with... Oh! No, that actually does. There we go. Okay. Totally good. I guess you just have to... I don't know. I don't know why the light... You can see the light just came on. I don't know why the light wasn't actually on originally. I thought that it would just be on when I plugged it in. But maybe you actually... It might be that you have to actually load X input for it to actually go on or something sometimes on older versions. I don't know. Normally when you just plug it in, it just works. But I guess because this machine perhaps doesn't actually have the little X input helper, the little X box controller app or whatever, maybe it doesn't. But that's pretty good. That was it for controller support. I mean, you saw that was like hardly any code, right? And we did it the hard way. We did it loading it ourselves. But you can see, I don't know if you can see there, when I push the button, it totally works. So we're basically done. I mean, that's the controller input. There is nothing else to it. We can go ahead and send Rumble back to it, so I guess we might as well. I don't know what else to say about it other than, hey, that when you actually make a good API, ladies and gentlemen, which X input actually isn't that bad. It's got a few things that are kind of annoying, but on the whole, it's pretty easy. Look at how easy it is for people to program, you know? It's a good thing. So I guess what I could do here is just call get X input set state just to verify that it sort of worked. I could go ahead and just send that to the 0th controller. Yeah, and we'll just send some Rumble level out to it just to verify that it's actually working, and then we'll save that for some other time later when we actually have some really coherent thing that we want to do with it. So I'm going to go ahead and look up X input set state here just so I can see what the parameters are of that structure you got to fill out that it passes to it. X input set state. So it's called an X input vibration. Let's take a look here. X input vibration, and it is just left motor speed and right motor speed. That is it. All right, well, that should be easy enough. So let's take a look. Vibration dot w left motor speed equals something. What is it? It's a word. All right, well, if it's a word, I mean, clearly, if it's a word, we're going to want something close to the highest value because we want some serious rumble on here, right? That seems to me like a good thing. Maybe not quite the highest, not 65536, but we're up there. And let's take a look and see what happens here when I run that. Look at that! Vibrating nicely. I don't know if you can even see it vibrating, but it is definitely vibrating. All right, well, there we go. That was the adventure of X input. Not a whole lot to do, and good for a day's work. So, while we have time, we might as well add keyboard input too, just so we can see how to get that, so that when the time comes and we want to wire this up to our actual game code, we will be ready, because I'd like to have keyboard input as well, not just joystick input. So I'm going to kind of go up here and show you how to do that. It's real simple. Basically, for the kind of basic keyboard input that we're looking for, there's a more advanced kind we'll do when we do like the shipping version of the Win32 platform layer, which is way down the line. Basically, there's a thing called raw input that we would use to be able to handle multiple keyboards that are mapped to different players, which almost nobody supports, but you can do it. And we might as well do it. But in the meantime, there's basically sys key downs and sys key ups. Let's see, sys key up, and there's key down and key up. I think that's basically it. And I'm not sure, I don't remember these at all, so we're going to look at them. I don't even get input this way anymore. Like I said, I usually use the kind it's significantly a little more complicated, I would say, but you get a little bit more from it, so it's something we'll kind of cover more in the future. But you definitely don't want to start with it because it's a bunch of complexity that you don't need for anything other than if you actually want to handle multiple keyboards. So let's take a look here. So in sys key down, the W param is the virtual key code. And the virtual key code is basically the thing we want. So what Windows is going to do is Windows is going to call us back with these messages whenever anything happens on the keyboard. Now, you don't need to register anything. It just happens. Windows will always send these to you. And normally what was happening before is they were going into here. They were just getting eaten up by the def window proc. So all we're going to do is start actually looking for them. That's it. So basically, the W param is the virtual key code. The W param is the thing that comes in here. It's just an anonymous parameter that depends on what message you have. So the virtual key code is this. So let's go ahead and mark that off. Is that true as well in sys key up? Let's see. Sys key up. Yep, it is. Let's look at key down. And key down message. Let's take a look at that. The virtual code of the non-system key. Yeah, so basically it always is going to come in with the VK code there. So that is exactly what we wanted. We want our VK code. Now I'll tell you what a VK code is in a minute. But for now, suffice to say, it's just a thing which tells you which key it was. But there's also this other thing, which is the lparam. And the lparam basically tells you some additional things about the what went down, basically. And so there's the previous key state, which is bit 30, right? So if you shift 1 up by 30, you get bit 30. If we take a look at lparam ANDed with that, that tells us whether the key was down before the message was sent or up before the message was sent. And so I don't know why you would receive key down messages if the key was already down, but it may be because of key repeat, if that makes sense. Like, you hold down a key, like this, and it keeps going. I think that might be the case, and we'll double check that. But for now, let's go ahead and just say, okay, no matter what happens, we're going to get basically a VK code out of it. We're going to see what the W param is. That tells us what key actually went down, and we're just going to look for the keys that we actually want. That's all we're going to do. We're going to take a look for those individual keys. And the keys that I actually want basically are VK. I think these are the way that they are listed. I'm going to see if there's actually a VK code listing somewhere. Let's see. VK code listing. Because I don't remember what they all actually are, because they have different names sometimes. So you can see, all right, so here you go in MSDN. There's a listing of all of the VK codes. And the VK codes are basically all of the codes that don't have direct ANSI mappings. So basically, you remember the ANSI key code stuff we talked about in the Intro to C stream? Well, basically, all of the ANSI keys actually map to their actual ANSI equivalents, right? So if you actually in C, if we wanted to, let's say, test for the W button, you could actually just do that, and it would work. At least I believe it is always the capital. Yeah, it maps to the capital, if I'm correct, if I remember correctly. Yeah. That is the W key, and we'll double check this to make sure it wasn't the lowercase and I'm totally wrong. Well, you know what? We can just do it right now. Output debug string A, W. Very exciting. All right, let's go ahead and run this and get this window over to the side there. Where's our output? There's our output. W, there it is. You can kind of see it Wing out there. Always good. So that's all we really needed for any of those. So if we want WASDF, basically what we're looking at is just something like this. Really, really trivial code here. Nothing particularly interesting. So if we want the full complement, let's say WASD, and of course the ubiquitous Q and E. You always need those special options. That is basically that. Nothing particularly interesting there. And then we just need to know stuff like, say, the arrow keys, maybe the space bar, and then probably escape. That's kind of the stuff that we would expect to get back in a game situation. I think that'd probably be pretty good for now. So we've got Q and E, and then we go in here. We're going to need VK up, VK left, VK down, VK right, VK escape. Is it escape or just esc? I wonder. I don't actually know. Let's take a look here. You can see these left, up, right, down. There's home and end and all these other good things. VK escape. So it is escape fully typed out. And then what else did I say? Space bar is a typical one. Is the space bar mapped to just space, or does it have an actual space in it? VK space. There we go. So that's it. That's basically all there is. And those are all the key codes that we might want to handle. Now, what we're going to do with those is going to be determined once we actually get our game stuff working and we have a place to wire input up to. But I just wanted to show you, so that there was no confusion, basically what was going on. And so we can also get some more information here. Like I said, this is going to be basically a was down, which is basically saying, oh, okay, was the key down beforehand? So that's like if this is not equal to 0, then the key was down. I'm basically just turning that into a guaranteed Boolean. This bears a little explanation. Again, this has been a pretty good stream in terms of having plenty of time to talk about stuff, so I'm just going to say what I'm doing here. So basically, this L param is a bit field. It's got a bunch of bits set. It said that the 30th bit tells us whether or not the key used to be down or used to be up before this message, before whatever key event triggered this message. Well, if I just AND those together, then what I'm going to get is I'm not going to get 0 or 1. I'm going to get 0 or bit 30 being set, which is way not 1. And since I wanted to sanitize it into a 0 and 1 potentially, since I was going to put it in a bool, I don't know. I don't really have to put it in a bool for any particular reason. We'll talk about that kind of a little later on, maybe. Maybe we'll even talk about that tonight since we've got extra time. I just said not equal to 0. That comparison, if you remember from the intro to C stream, we were talking about it, and I think I was actually even a little unsure about it at the time, which is kind of odd considering the fact that I would have known that this happened, but what are you going to do? Sometimes when you're on stream, you're a little crazy. Basically what happens is if you ask C to do a comparison for you, it will produce 0 or 1. So if we do not equal to 0, that will actually produce a 0 or a 1, depending on whether it was a 0 or the bit 30. So that's basically just turning, it's basically turning, this, we got back either this or 0, right? We got either that or this. But what we wanted was this or that, right? We wanted this one to turn into 1 and this one to turn into 0. And so the not equal to 0 just basically forces that to happen, right? That's about it. All right, so that's a was down, and then I also want an is down, meaning what actually was this message trying to tell us. And so let's take a look at back to the WM key down message, and what does that actually say? Okay, the transition state, what is the transition state defined to be? Always 0 for a key down message. So what is the key up message? Is it always that as well? Always 1. All right, so the transition state, so basically the other bit will tell us what it actually is now. So basically if that bit is set, am I correct? For a key up message, it's always 1. So we want it to be equal to 0 if it's down now. Is that correct? Because key up, yeah. So let's take a look. Basically, I'll go ahead and test this with, say, the escape key. So when we put that, I'll do an output debug string, and I'll just do a test on is down, right? Let's see. Do it this way. And was down, right? So we'll do output debug string escape, and then we'll say is down, was down. Excuse me, I'm still sick, ladies and gentlemen, it's true. I did not recover much over the weekend, unfortunately. Then when I run this, I should be able to kind of go in here, take a look at that output stream, and do my escape key. Well, that did not work particularly well, to say the least. Why is my escape key not working? Oh, that looks like it didn't compile. What happened there? Why am I... How did that happen? I thought I compiled it, and yet it was still printing out W, which we deleted. So I guess I didn't compile? I don't know what happened there. That clearly looks like I compiled. Maybe I did something else wrong. There it goes. Yeah, I don't know. Ladies and gentlemen, programming. It's always a little wonky. Okay. So I hold it down, it is down, and it was down. That's correct. So I am getting key repeat messages, so I get them repeatedly. Then when I let go, I get just was down, and that's correct. Yeah. Perfect. So, looks like that's all good. Basically, we have everything we need here. We don't need those key repeat messages. So one thing that we could do if we wanted to is we could just kind of get rid of them. We could basically say that if was down equals to is down, this is not an interesting message for us, if that makes sense. We could just flat out say that. And then when we run in here, we will basically be eating those key repeats, right? Let's see, there we go. Is down, was down, no, oop. Did I do that the wrong way again? Yeah, awesome. I do that all the time, people. All the time. What I wanted to do was say if they're not equal. I want it if it wasn't down and now it is, or if it is and if it was and then now it isn't. So I want them to be not equal. I basically filtered for the case we don't want. That's brilliant. That'll help a ton. Way to go. Good job. So there we go. That's what we wanted. Yeah, exactly. Perfect. So that's really all we want, and that is pretty much the entirety of key input as well. That's it. So we've got input now. We just need a game to funnel it to. And like I said, we don't want this. I mean, this is not good code that's going to do anything useful for us. I just want to put in there so you can show how to get at everything. Once we actually have something to fill out, what we'll be doing is in here, we'll just go ahead and say, okay, let's pass, let's fill out the stuff that we're going to pass to the game by using these things. So that's all we're going to do. Well, here we are at the 5-minute warning. We have already accomplished everything that I wanted to accomplish on that stream. Let me think if there's other things that I might want to do real quick. One thing I wanted to do is I got email from people over the weekend. This was supposed to be a win class A. Remember, I was trying specifically to make everything be A's where they should be. And so load library is also an A kind of a thing. So I'm going to try and go in here and just pass A to everything so that we know that we're not using Unicode for the benefit of people at home, just to make it a little easier for them if they're compiling in Unicode mode. Since we are not, if they are for some reason trying to do that, then this will make it a little easier on them just if we have most of them correct. Okay, I guess get proc address only has an ANSI version. There is no Unicode version of that. So that's good. All right, that's all set. Let's take a look and see if there's anything else here that I wanted to take a look at. Yeah, so there is one more. One of the things I was thinking about over the weekend is and I asked some friends about it too, just to be sure. I decided I don't really like this passing by value. I mentioned it real quickly. I was talking about passing Win32 off-screen buffer by value, and really passing something by value in the hopes that it's going to optimize stuff when it's that big, when it's something that large, that is a fairly large struct. It's more than it's not like a tiny little struct. It's fairly sizable. I think in general you're counting on inlining. You're counting on the optimizer inlining this before it's really going to get a win out of that. And if it doesn't inline it, then it's going to be a problem because it's going to force copies and stuff like that. So I want to actually go back to the way I normally code. I kind of did that for the benefit of the people watching. But honestly, it's not something I would actually do. So I'm just going to go ahead and change it to the way that I actually do things and not try to be overly clever on the stream. I think that was a mistake. And so I'm just going to actually kind of rearrange the code here and just make it a little bit more like what I would normally do. And just because I think that's the right thing to stick to. I mean, I should stick to how I code. And if I want to mention something that other people do and say you could try to do this or investigate on your own, I think that's good. But I shouldn't try to do things that aren't the sort of things that I normally do just because they might be better or maybe they're newer ways of doing things. Because at the end of the day, I have no guarantee that they are actually correct, and I may just be leading you astray. So I'm going to go ahead and just clean that code up a little bit and make that look a little bit more like what I would have expected. Okay, so we are almost done with that. There we go. And now we are compiling again. And I think that is it. We are still in good shape here. We've got 3 minutes. I don't know what else we should try to throw in here in the 3 minutes. I guess one thing we could do is we could go take a look at the set cursor situation. Since we're still not setting the cursor, we could try to throw full screen in there 2 minutes. I don't know. 2 minutes. Maybe we just go to Q&A early. Maybe we just say that was a good day. We got everything done that we wanted to get done. We've got input in, and so we'll have the rest of the week to work on sound, which is really the only thing. Well, we got two things really: sound and file I/O. So if we can get through sound in 3 days, we could do file I/O on Friday, and then we would pretty much be ready to get going on the game proper the following week, which would be great. 2 weeks on Windows is not very much to spend. I mean, that is longer oftentimes. I'm sorry, that is shorter oftentimes than it takes to figure out why your CSS isn't working on when you're trying to make a web page. So I think that's probably pretty good. All right, I will go ahead and go to the stream now to see what is going on over there. Let's take a look. Can you write a driver to make it work with PS4? Okay. lparam 30 is always 1 for WM key up. Yes, that should be true, but that's okay. We don't care. I'm not sure why that would matter. That we don't actually care if that's true, right? Because we just want to make sure that we're turning whatever these 4 messages, these 4 separate ways that Windows is going to tell us about key events. We just want to make sure that we turn them into something reliable. And whether it was down and whether it is down are usually pretty reliable things in my mind, because it kind of lets you know which direction you're going. It kind of makes it so that no matter what the message was, you end up with a stable state that you can record in here. So that was just kind of a way of decrypting that into something easier. Okay. Not a criticism, why uppercase variable names? Really, it's something that I got in the habit of doing at my very first thing, which is when I was programming with Chris Hecker, actually. There is no reason for it. It's just how things were done, and that's what stuck with me. I don't think there's a right or wrong way to capitalize your variables or anything else. Okay. Can you explain your macro and referencing the X input functions again? I certainly can. Let's see here. So, in here, what I did was I said, well, this is the function prototype that Windows made for X input get state, right? This is what it looks like in the Windows header file. So what I did is I replaced the name X input get state with basically a macro parameter. So that allows us to make as many functions of this signature as we want just by using this macro, right? This macro will basically generate the function signature and swap in whatever name we give it. So to define a type that is that signature, right? The type is this function signature. I just do type def, then I let the macro expand this thing out with the name that I want my type def to have, right? Then I do the exact same thing to generate it again, only this time with a different name, and that generates the function, the actual header for my function, which I then have return 0. Finally, I make a global variable that points to it, and then I define basically X input get state from now on to to use my new pointer that I declared, because I can't undefine the one that Windows had, so I just renamed basically everything from here on out to use this one. There's really nothing magic going on here. It's, I guess it is something that only I do, because I posted, or maybe other people do it, but I've never heard of it. It's basically something that I posted in one of my Windows dev blog entries, and I got email from people going like, I'd never seen that before. That's pretty cool, or something like that. So I guess it's not that common, but it's the only way I ever do it. So the only way I ever do function pointers is I pound define a thing that generates the signature. I type def using that macro, using the pound define. I make the type def to the type. I define the pointer by using that new type def, right? And I define the stubs by using the macro. It just works really well. Because it works especially well, you'll see later on, when we want to do dispatch tables or something like that, and you've got a lot of functions that all have the same signature, and you want to be able to change them trivially. Having them all go through this macro means you can just change one line and have all your functions have new function signatures. It's pretty cool. Let's see. What's the size where copying becomes problematic for a struct? I don't know. You'd have to time it. It probably depends on the platform. But in certain cases, like for rect, for example, we still were passing that one by value for a while. And earlier, we're not doing it anymore because we don't pass the rect to anything. But something like rect, where it's 4 32-bit values or something like that. Let's take a look. I don't actually remember. I think it's 4 32-bit values in a rect, right? Yeah. So if you have something like 4 32-bit values, that seems like something you probably want to just pass by value, because you wouldn't bat an eyelash, right, at having a function where you were going to do something like, int star A, int star B, right? But in 64-bit code, that right there is 128 bits, which is the size of the rect struct. So it's really not a big deal with something small like that. But once it gets big enough, yeah, I would say, you don't risk it, pass a pointer. Now the problem is, how do you know where that breaking point is? And the thing that I want to emphasize, this is something that I actually wrote down here that I wanted to talk about, and I'm glad it came up because I was going to kind of force the issue here in the Q&A if it didn't. But basically, it's something that I want to get across that I didn't do a good job of getting across. In fact, I probably exacerbated the situation last week, is don't think about optimization at a low level until you actually are optimizing at a low level. Because if you're constantly thinking about how to optimize your code at a low level, you're probably just wasting your time, because low-level optimization is very difficult and very specific. And a lot of times if you're like, oh, I'm typing along and I decide to pass this thing by value because it'll be faster, you don't know if it's faster, and you're not going to spend the time right now to check, right? And there's so many things that are interdependent in low-level optimization that you're just likely to be wrong all the time. So what I'd like to emphasize is program in a way that doesn't create obviously bad things. Like, don't do anything that's going to be disastrously bad. But other than that, try not to constantly focus on anything low-level optimization-wise, because you're probably just wasting your time thinking about that, and you might be actually making things worse by doing things assuming that they're helping and they're actually hurting, and so on. So I would say you want to write your code in ways that are nice and clean and simple, because that is what will be easy to optimize later. So you should always be thinking about that, but don't spend too much time thinking about how to do like crazy little optimizations. For example, in fact, someone just said this. They were saying, instead of writing it this way, why not write it this way, right? And then not have to do that thing. And the answer is because that's way more obtuse, right? At some level. It's just more confusing to look at that. Really, what you probably should do in this code is something more like this. You should say like like key message was down bit, right? Like this, you know, or something like that. And just so that you actually are testing against things that make some sense, if you know what I mean. This is probably an even better way to write this, because the compiler is not dumb, and it's probably going to be able to generate the right code out of this either way. So, you know, that's just a cleaner way to do it, in my opinion. Yeah, I don't know. But either way, I don't really care. Again, like, you should write those sorts of things however you want to write them. Whatever makes it cleanest and easiest for you to understand and remember, because this is the kind of thing that really just doesn't want to be done at this stage in the code. If you are thinking about how to write this more optimally, you are totally wasting your time. Because A, the compiler will probably do the right thing no matter what you write on that line, because it's so simple. And B, if the compiler isn't doing the right thing, rather than guessing what will be the right thing to make the compiler do, you actually should, if you're like, I'm going to optimize this now, you should look at the assembly, see what's generated, verify that the thing that you're writing is faster, and then you know. And so I really want to make sure that people aren't getting hung up on this. I'm talking about low-level programming because I like the control, and I like to be able to do the optimal things, and we will be getting to those sorts of things. But I don't want to create some kind of a thing where people are thinking they always have to be thinking about exactly what the compiler is going to do and how to make it the most optimal, because that's actually going to cross into unproductive. So you need to know what your code is doing. You need to know what you're telling the CPU to do. But between you and the CPU, there is that compiler, and it will do inefficient things, and you don't have to always worry about wrestling with it. The time will come when we start to wrestle with it, but until that comes, you know, maybe just try not to fixate too much on it. Let's see. Let's see here. How does the dynamic linker find the Xinput library installed on the user's machine? Is it allowed to link Xinput at compile time or distribute the Xinput DLL alongside the XML to ensure the dynamic linker can find it? Okay, that is a good question. So basically what happens is when we call load library, it is going to look in a number of places. And in fact, I believe, and I don't know if this is true anymore, but I believe you should be able to actually read it out of the documentation here, because I think they actually document the series of steps it goes through to find the file. Now let's take a look if that's actually true. Maybe I am totally wrong about that. Okay, here we go. The first directory search is the directory containing the image file used to create the calling process. So first it will look where our executable is, right? Or wherever we installed our exe, it'll look there. So basically what we could do is we could dump an Xinput DLL that we wanted to use into that directory, for example, and then it would always load that one. Okay. So that's fine. Let's take a look here. The search path can be altered by set DLL directory. If a path is specified and there's a redirection. Okay. Is the path variable to load a module from a relative path without switching another path? Get full path name. Here it is. Dynamic link library search order. Factors that affect searching. Okay, so this is the page you want. This is what you want to read if you want to know everywhere that it goes through. I'm not going to try and read all this because, oh my god, right? Like, look at all that. Suffice to say, it will look wherever our executable is. Then it will look in like the Windows system directories and stuff, which is where stuff gets installed when it's system-wide. So if we wanted to ensure that X input was redistributed with our game, we could do that, and we could just put X input in our directory. But it's unclear whether we actually need to do that, because usually if the person has an X input controller, they will have gotten the little redistributable thing that comes with it, or installed the little helper function that'll install it, or they're using Windows 7, which has it installed by default, and so on. So we probably don't need to do that. But if you really wanted to, when you did redistribution, yes, you could go. In fact, they might even have one. These are typically called redistributables, and you can look for X input redistributable. And there might be a thing which basically says how to do that. And let's take a look. Okay, so basically it says here that there is a redistributable as part of the SDK. So you may be able to go into the Windows SDK and get a little redistributable that they have made for you that you can just run that'll install it on the user's machine if you want to. I don't know. I usually try not to do that. When I ship stuff, I try to make it so that it just works on the user's machine. So what I usually do is I load library, the earliest version of the DLL that I can find, that I know will work, which in this case is this one. And so then I know that almost everyone, it will just already be on their machine and work. And if they don't have it, then they don't have it. They can always choose to install the X input app thing, and then they will magically get it. So they can always, I can always have on the web page, if you would like to use a joystick with this and you have an older version of Windows, like Windows XP, just go ahead, go on Microsoft's site, here's the link, download the X input application and install it, and then you will magically be able to use the X input with your game. I tend to like to do that a little bit better, just because I find that most things you can get are already on the person's machine as long as you use old backwards compatible stuff and don't force to have the newest. Like, that's why I didn't put X input 1.4 here, right? I find that that's better, because then the user isn't like, oh, I'm running, in order to install this game, it just installed all this crap on my machine, and I don't even know what half of it was, and oh, there's the VC library and all this other stuff. I don't like that, so I try to keep that as minimal as possible for the benefit of the user. Let's see. You had a second part of that question. Is it allowed to link X input at compile time? So no, it can't really link it at compile time. That's not really an option. The thing that it's linking at compile time is just an import library that itself calls, like, this basically is more or less what actually happens when your program is loaded in Windows, right? It's going to go ahead and it's going to look at the things that were in your import libraries. It's going to get their addresses, much like this, and then the only difference is instead of it being pointers that we manually dealt with like we did here, it's just going to patch them in. It's going to patch those pointers into direct memory locations in your executable, but it's basically the exact same process. So that's just what's going to happen. If we didn't do this, Windows is just doing it for us. And that's how Windows is, Windows is already doing that for a bunch of functions for us, like get client rect and so on. That's what's happening there. It's getting, the loader is doing that. Let's see. There was a question earlier about why you chose an if-else cascade for key input instead of a switch statement. It's up for grabs. Okay, so basically, the reason I chose this is that I wasn't really trying to write any real code here. So basically, this is just going to sit here until we actually have something to pipe to, and we may well switch it to a switch statement. That would be totally fine. In fact, we can, you're welcome to basically recode it like this if you would prefer. It does not matter at all. Like I said, this isn't real code right now, just showing you how to get it out. I just wanted it to be there so that later when I go, okay, it's time to add input now, and we add it in the game, I can just go out here and I don't have to explain anything. I can just hook it up and we're done. So this is just showing, I was just trying to show people what comes in and how. So yeah, this is not a choice. It's not a smart choice or a dumb choice or anything. It's not even a choice. It was just saying, hey, this is how that would work. When will I break the giant header off of the main CVP file? So you're talking about, I assume, this stuff. Basically, excuse me, probably next week, would be my guess. How do you know the X input stub things work without testing it on an XP computer without X input installed? I love that question. It's like you read my mind. You know, it was going to be a secret, but because the question was so good, I'm just going to say, I don't know if anyone noticed this guy sitting right here. Well, once we are all done with the Windows stuff, I was going to show you guys that exact thing. You see this guy right here, Windows XP? I did it. You didn't believe I'd do it, I bet, but I did. I installed a Windows XP virtual machine. I actually have a bunch of Windows XP licenses because I used to have essentially a render farm, and that totally is decommissioned now. So I've got like a stack of WinXP licenses. So I took one of those, installed it on here, and now I've basically got Windows XP, a fully legitimate, actual fully licensed one. So we can run it for as long as we want. It's not even one of those like 30-day trial about to undo itself kind of a Windows XP. It's like a full-on version of Windows XP Pro that we can launch and test on. And that was, I was going to do that. I was going to be like, at the end, it was going to be this big climactic moment of like, how do we really know? And then we're going to run it on there and all that stuff. But you beat me to it. But it was such a good question. I felt like I had to let the cat out of the bag. Now, what I will tell you is, as of right now, there's absolutely no way that we run on Windows XP, I bet. And the reason for that is because I think you even need to pass special flags to the linker right now to make that happen, because by default, Microsoft's compiler like doesn't even output stuff that runs on Windows XP. That's how bad the default setup for the compiler is. It's really sad. That's just the way it is. So I can pretty much tell you definitively, yeah, that we don't run on Windows XP. And so what we're going to do is we're going to run it on there. I'm going to show you that it doesn't run, and I'm going to show you the flags we need to set to make it run. And then we will also be able to verify that we're not calling anything inappropriately that causes us not to run on there. And so that's a great question. And the answer is the only way to do it is to test. So I highly recommend you always have a virtual machine or actual machines with the platform, different platforms that you want to ship on there, the minimum one especially, so that you can figure that out. Is it a waste of time to check if get proc address returns 0? So, you know, I don't know. I mean, that's a good question. If you wanted to be really, really stringent about it, you could reassign to the stub here. And actually, in my actual real code, I do actually do that. I do a thing where after these, I basically do, you know, if not get input state, x input state equals x input state stub. I actually do that normally. Just to make sure that I don't get a bad one. But, you know, is it a waste of time? Yeah, probably, because you are so far, you're basically guarding against something that's kind of meaningless. Like, if you loaded this DLL and somehow someone had modified the DLL to not have the functions in it that it normally has, then, you know, who's to say that the functions even work at all? Like guarding against it, not finding them is like the least of your worries at that point. You're probably about to jump into some real crazy stuff if someone gave you a DLL that bogus. You know, so do I think that's worth it? Not really. You know, I don't think that's particularly good. Yeah, you know, not my. I wouldn't say that that's a particularly good thing to do. We'll do it just because you asked, but yeah, I wouldn't say so. You know what? While I'm here, I feel like this kind of has to happen, right? I feel like we kind of need to do this. Excuse me. Something like this. Let's do plus equals stick x, stick y, you know, that sort of thing. And those are probably going to be pretty heavyweight. So we're gonna actually, that's probably still too heavyweight. Let's do that. All right. Oh, look, no, what's going on? That's no good. Well, oh, 8, that's duh. What I meant was like shift down by 8. I was trying to make the dead zone alone will be, eat that up. Let's see. All right, so here's my controller. That's still way too much. That is still way too much. Let's set that down a bit. So we basically want something like that, I guess. So very, very, very little back from the controller. Yeah. Oops, that's Y offset. Okay, there we go. And now we can control our scrolling. So that's always good. So that is interesting too. This guy is always a little bit left, isn't he? I thought this gamepad was busted. I was playing with this guy. I don't know if you can see that now. We're actually getting stick in there, which is, I don't know. I felt like it kind of have to happen. I thought this gamepad was busted. We'd been playing a bunch of games with it. Doug was over the other day, and we were playing a bunch of games with it. And it was like, I thought that it was always going the other direction. And I think it's like got a messed up dead zone or something, because it shouldn't be that, there's no way it should be registering that much all the time. I think this is just basically a faulty controller. I'm going to have to buy a new controller, ladies and gentlemen. Maybe this will be an excuse to order an Xbox One controller. I don't know if those work with X input yet. I assume they do. Yeah. Well, that's just lame. But anyway, that needed to happen. I think we all know it needed to happen. Let's see. All right, we're kind of out of questions, so I think we mostly got. I think we've mostly got everything. Oh no, we got a little bit more. Let's see here. RAII has no impact on performance. I would disagree with that. I would say that RAII does have a large impact on performance. That is one of the main reasons that I don't use it. So maybe we can get to that some other time. Probably not a good time to do it, but yeah, that's what I'd say. Let's see. Where do the W param and L param come from? Well, basically what happens is Windows calls us back here, right? So if we were to set, in fact, we can just go ahead and do that. So if we were to set a breakpoint here, like this, we get into Win32 main window callback. Basically what happens is whoever was above us in the call stack is the person who's supplying this stuff. And that stuff comes from user32.dll, so this is some Windows code. The Windows code, basically, it's the thing, right? It's the thing that's calling us back and telling us what window, what message, and what WPARAM and LPARAM, what they are. Now the reason they're called WPARAM and LPARAM is because it wants to call us back at just a single function. But it has all these different messages that it wants to give us. And each message has different parameters. So it can't actually put the actual types in here. It can't say like int wparam and void star lparam or something. Or, rect or something, rect star lparam. Because each message uses a different type. So basically what it's forcing you to do is use this message to go into a switch or some other thing and test where you are. Once you figure out what message you're at, it's incumbent upon you to basically decrypt those WPARAMs and LPARAMs, cast them to the right thing, or do bit operations on them to get out the values you need, whatever. That's basically what's happening there. And so the WPARAM and LPARAM are just basically anonymous parameters to, I think they're 64-bit. I don't know if they're 64-bit or 32-bit. Let's find out. Size of WPARAM. They are both 64-bit. So they're basically just two 64-bit values that take on whatever meaning they need to take on for the message in question. Let's take a look. Why did MS choose to use a link and import library approach like this rather than true dynamic loading? I'm not sure what you mean. Dynamic loading on Windows works. is no less dynamic than Linux, Unix-derived platforms. I'm not sure I understand that question. Sorry. Let's see. Will the game state be cleared once per frame? So I don't know exactly what that means. Resetting mouse positions, clearing booleans. I mean, some stuff will be cleared per frame if it's something that is only true for the frame. I'm not sure. Sorry, I don't understand that question necessarily either. Maybe wait till we actually get there, and then you can ask it more specifically at the time, and it will be clearer. Will you implement procedural generation? Yes. When are we going to get a Naysayer and Simuratori combination game? I do not know, but The Witness has both of our code in it. I mean, there's that. I think Braid even has some of my code in it. I think maybe the rounded rectangle intersection code is in there. I don't know. You'd have to ask John if that's still in there. I remember it was in there at one point. I wrote some rounded rectangle intersection testing code. I mean, it's like 60 lines of code in what's probably, tens or hundreds of thousands of lines of code for the game. But if all you care about is that you had a game by Jonathan Blow that also had some code from me in it, you already have one that you can play. What sound API are we going to use? Direct sound is what we're going to use. Will the OS free all heap objects on program exit? Yes. You do not need to free everything yourself. It will free everything. Let's see. On Unix, you don't need to link to a .lib file at all to use a .so file, whereas on MS platforms, you need a .lib file. I don't think that's true. That has not been my experience. In my experience, on both platforms, you can either use an import library and have it do the binding for you, or not use one and not. I mean, yes, you have to... Okay, so maybe this is what you're talking about. Maybe you're talking about the fact that you can directly say, I'm using this library, and you don't need a separate .lib that tells you what the import library is. But that's really a compiler thing. It doesn't have anything to do with Windows. That's just the way the compilers decided to output the executable stuff. You wouldn't have to do that, I don't think, if you didn't want to. The compiler could have just done it directly. I think it's just designed to save time, maybe even. Because the compiler could just read the DLL and output the code to bind to the DLL correctly, just like it does on Unix. So, yeah. I don't think there's as much of a difference as you think there is. I guess that's what I would say. But either way, I'm not sure it matters. Like, it's really not a thing that affects anyone, as far as I know. In the far future, will you use DirectX or OpenGL or what? Well, we'll probably use one of the two of them to do our blitting for us for speed purposes, but I'm not sure which one. We will probably use OpenGL if it seems viable at the time. Otherwise, we'll use DirectX on Windows and OpenGL only on other platforms, because sometimes OpenGL on Windows doesn't work as well, and so on. Let's see. We will be drawing the whole screen every frame, probably. I mean, not exactly true, but there's some things that will be sort of redirected, but we will be drawing the whole screen. Are we going to use the width and height in the paint variable again? No, I don't think we are. You're talking about in here. If you notice, they're already gone, right? Is that what you're talking about? I'm not sure exactly what you're talking about. But in here, we pass the window width and the window height only, so we don't... Yeah, I'm not sure exactly what you're talking about, but I think we already got rid of them, is my understanding, but I don't know. Let's see. Why does Valgrind make it look so scary when you don't free? Well, because they don't have anything else they can do, right? I mean, it's an external utility. It doesn't know whether that thing was a leak or something you actually meant the OS to clean up, right? Because let's say I allocate, at the beginning of the program, I allocate a buffer that I'm going to use for stuff, and then I don't free it, and I let the operating system clean that up. That's totally valid, and that works. But let's say I allocate something every frame. I allocate a new one every frame, and I never clean that up. Well, that's a memory leak. Valgrind, or Valgrind, I believe is how it's pronounced. Valgrind doesn't know the difference between those. It doesn't know what your intention was, right? So it kind of has to report them all. And you will have to kind of let it know, I guess, which ones, or you have to know which ones are legitimate and not, would be my guess. Let's see. It looks like WPRAM and LPRAM are 32-bit on XP. Yes, well, it's not really about XP or not. It's about whether you're compiling in 64-bit mode or not. So I suspect if you were using XP 64, and you were loading in the 64-bit mode, they would probably be 64-bit. It's really just whether you're 32-bit or 64-bit is whether they're bigger or smaller. We're compiling in 64-bit mode, so they're 64-bit. And we are basically at the end of the questions. Is it possible to keep your frame rate consistent while dragging the window around? Doing repaint on WM Move is slow. So here's what I'd say about that. I have noticed a lot of people have been doing some crazy stuff with the Handmade Herosaurus, like trying to time the frames per second and stuff like that. I would highly recommend not doing that. We are just setting ourselves up so we can learn how to write a renderer, and we'll be timing the code in the renderer because we want to make that fast, but we're not, like, right now we're just using a Windows call that's probably on the slow path to blit things to the window. So don't time it. It's gonna be way slower than it should be. Like this is not, we're not trying to get a fast blit going here. We're just trying to get something reasonable to the screen, blitting in an easy way that allows us to do our own bitmap rendering. And then when we are done with all of that stuff, then we can start to look at, okay, how do we get that stuff to the screen fastest? Because that's a whole separate thing, and I don't want to put the cart before the horse. That is way down the line, because we haven't even seen how to like draw a game yet. And so you don't want to try to draw a game fast before you know how to draw a game at all. So hold off on that. Don't go nuts. Timing this code is totally pointless because we probably won't even call stretch bits when we're done. Stretch bits when we're done. Okay, everyone. I think that is the end of the stream. So thank you very much, everyone, for tuning in. It has been a pleasure, as always. Today's stream went so well, we basically had more time than we even needed. So that's good. Let's hope that continues. Tomorrow, we will pick up where we left off with doing basically direct sound so that we've got our input. We'll start doing our sound. So hope to see you all again. We are also trying to get the forums and stuff up and running, so maybe by tomorrow we'll have that too. If not, hopefully by the end of the week. So thanks everyone for joining us. I hope to see you here again tomorrow at 8 p.m. Pacific Standard Time. That will be the last 8 p.m. cast for this week because we're going to have holiday hours for Thanksgiving. Wednesday, Thursday, Friday will actually be at 11 a.m. In the morning. Because everyone's going to have Thanksgiving things in the day and parties and all that stuff. So we're going to try and put it in the morning where people might be able to catch it. And then next week we will go back to our regular schedule after that. So thank you very much for joining us. I hope to see you here for the rest of the week when we add direct sound. And yeah, that's it. Thanks for tuning in.